Hey guys, it's Microbit Labs here. I wanted to show you something neat. I, I have here a kind of a model of a garbage can. Now, this wouldn't be a very large garbage can, but that's besides the point. This is potentially a garbage bin. And on the front, I've taped a little sensor, and it works with sonar. One speaker here sends out a signal, and the other receives it. And it kind of works by sonar. And by timing a sound that gets pinged back, you can actually tell how the proximity, how close you are to something. Now, what we have here is a microbit. I've programmed it, I've flashed the program. It's not on right now, but I have 4 wires going to this proximity sensor. The unit is called an HCSR04. HCSR04. You could probably find it on Amazon. Actually, I'll probably have an affiliate link in the notes. But long story short, there are 2 sensors here. There's the proximity sensor, and then there's inside here, inside this garbage can, there's a servo. So let me go ahead and turn on my power source. Now you could just plug this into USB or whatever, but I have a so I have a power source. Now I'm going to turn the switch on here. And so it starts off there, and so far it's not doing anything. Now if I were to walk in front of this sensor, the garbage can opens, and if I walk away, so I was about 51 centimeters. As soon as I walk away, it closes. And again, if I walk in front of it, it opens, and if I walk away, it closes. So imagine you work at a restaurant, and there's a lot of flies, there's a lot of mice, and people don't close the lid on the garbage. You could literally program a system that would open and close a lid on a garbage just by proximity. So I hope you enjoy that. This is really neat because it combines 2 things, a proximity sensor, and here you got a servo. Hey YouTube, it's Microbit Labs here, Mr. Murphy. I wanted to showcase a project I did based on this image. Hopefully you can see it pretty good. Basically, you have a guy maybe walking up to a garbage can or a recycle bin. When he approaches, the bin will open, based on the proximity here in the servo, the microbit. So some of the goals for this, for let's say grade 9 science in Ontario, is to learn a little bit about engineering, process, design, testing, building, models, structures, systems. Also, applying coding. So without further ado, we could talk a little bit about pseudocode. And when we program, so I'm talking about programming here for a sec, before you start programming in the Microbit code editor, you got to kind of think about what is it that you're trying to accomplish. So it takes a while to learn how to program. You can learn in little bite-sized chunks, I guess. Many of the best programmers I met are self-taught, and they just start with Hello World and they keep teaching themselves. But nevertheless, us programmers do something called pseudocode, and it's going to look like this. You keep looping forever in your program, and what you do is you're constantly detecting with that little sonar sensor how far away things are. So, and you store that number of the distance in centimeters into a unit called distance. And if the distance value is less than 100 centimeters, so if you're within a meter of that garbage can, then you open the lid. And what that means is you turn the servo 90 degrees. Else, if the person walks away and they're more than 100 centimeters from the garbage can, you close the lid or bring the servo to 0 degrees. So in the programming code environment, there's something under the logic drawer. It's called an if-else block of code. And this little diamond shape is called a Boolean value. And Boolean values can be true or false. So under the logic code drawer, not only do you get an if-then, if then else, you can also have a number comparison block, and it's kind of I'm tempted to say diamond shaped, but maybe that's more of a hexagon, perhaps a stretched out hexagon. So you have your distance, which is how far away the person is from the sonar sensor. Less than 100, we open the garbage can. Else, we close the garbage can. So then you've got to look at your servo and your sonar sensor. How do you wire them up? Just for the sake of brevity, I'm going to just highlight these two things. If you need to look at them, go ahead and pause. But let's move on. Once you wire those, the servo and the sonar sensor, you should, as maybe a young programmer, just try to implement them at their most simple level. So for example, if you press button A, turn the servo to 0 degrees. If you press button B, turn it to 90 degrees. Also for the sonar sensor, how do you get the value, the distance, the proximity? And generally it's surprisingly easy. You just have this circle in the sonar drawer, and I'll show you that in a minute. And then you apply it to set distance. So in my little note here, I had shown some sample code, and I'll expand these if you want to look at them. To be honest, it took me 3, 4, 5 iterations for the code, and I had to learn, like, mistakes and little misunderstandings. I'll give you an example. The sonar sensor occasionally returns a value of 0. So maybe once every minute it returns 0 once or twice. So what I realized is I don't want to just open the lid when it's less than 100. What I tried to do is open the lid when it's between 100 and the number 1. And what that does is it kind of bypasses those 0 errors. So remember this logic. If distance is less than 100, so you could say if it's less than 100 and greater than 1. Okay, so there's kind of something called a compound Boolean, what would you call it? Hexagon here in the logic. You have this and this, and you can build compound Boolean comparison operations. So long story short, I've challenged my students to go through the engineering design process, basically build a system that takes input from an external peripheral, judges that input and then reacts accordingly with output. And those two scenarios could be in a plant watering system or in a subway floodgate. If there's water, close the floodgate. Sadly, Florida's about to experience a hurricane this week. It's late September 2022, and they would be well served to have flood mitigation technology, especially with rising sea levels. Okay, so what I can do also is show you my servo proximity, maybe my latest iteration. So on start, I show this kind of neat graphic. This thing here is kind of a garbage can. And then in a forever loop, this is pretty well what I do. I get the distance from the sonar echo, and this was my compound Boolean. Maybe I could zoom in here so you could see it a bit better. This is my compound Boolean operator. I want it to be greater than 0, but less than 100. What this does, I could even say greater than 1. It avoids those 0 proximity readings that occasionally happen, and the garbage can just opens, without anyone there. So if you are close to that garbage can, less than 100 centimeters, you open the garbage can. You could pause for a second so it's not opening and closing really jittery. Else, if that's not true, then you're further away from you're further away than 100, or it's at 0. Either way, in those two scenarios, you want to close it. You close the garbage lid. Now, I've even noticed when you print out the distance to the LCD screen, it's kind of an I/O operation, input-output, and it kind of makes it sluggish. So I kind of set it up so that it would only very rarely show the distance. And I would only show the distance when the situation changed. So long story short, that's my code. I demonstrated the final project to you in the earlier part of this video. So I hope you enjoyed. If you found some value out of this, please like, comment, subscribe, and we'll see you in the next one. Thank you.